Welcome to this presentation on occupational health and hygiene, focusing specifically on physical hazards in the workplace. Today we delve into a critical yet often overlooked environmental concern: noise pollution. In industrial and daily environments alike, sound surrounds us constantly. However, when sound becomes excessive, unwanted, or harmful, it transitions into a hazard capable of producing severe physiological and psychological impacts. Throughout this session, we will examine what constitutes noise pollution, its primary sources, how it is measured, its effects on human health, and the essential strategies and regulations used to mitigate its risks. To understand noise pollution, we must first look at the term itself. The word noise originates from the Latin word noxia, which translates to injury or hurt. At its core, noise is defined as an unwanted, unpleasant, or annoying sound created by the vibration of matter. Biologically, these mechanical vibrations impinge upon the eardrum of humans or animals, setting up a nervous disturbance that our brains process as sound. When the resulting sensory effects become undesirable, disruptive, or harmful, that sound is classified as noise. From a purely physical standpoint, there is no inherent distinction between sound and noise. Both consist of acoustic waves traveling through a medium. Sound itself is a sensory perception, and complex patterns of these waves are labeled depending on context, such as music, speech, or environmental noise. The difference lies entirely in human perception and intent. When sound disrupts our focus, peace, or well-being, it becomes noise. Consequently, uncontrolled sound has emerged as a major, stress factor in modern human environments, posing significant challenges across workplaces and residential spaces alike. What exactly is noise pollution? It refers to unwanted sound that disrupts an individual's quality of life or daily functioning. Sound becomes undesirable when it interferes with essential activities like working, sleeping, or holding a conversation. Unlike other forms of environmental pollution, noise is often underrated because it cannot be seen, smelled, or tasted. Yet, its health impacts are very real. Highlighting its severity, the World Health Organization officially stated that noise must be recognized as a major threat to human well-being, emphasizing the need for active monitoring and control. Noise pollution stems from a wide variety of sources across our daily environment. Major contributors include street traffic from cars, trucks, and buses, as well as high-volume railroads and overhead airplanes near urban flight paths. Heavy construction sites also generate significant sound levels through earth-moving equipment and power tools. Additionally, household and commercial consumer products contribute to ambient noise. Identifying these diverse sources is the critical first step toward developing effective noise management policies, engineering controls, and personal protection measures. Noise intensity is measured in units called decibels. To put decibel levels into perspective, a whisper registers at around 20 decibels, while a quiet office environment averages about 40 decibels. Normal, everyday conversation typically sits around 60 decibels. However, once sound reaches approximately 80 decibels, it begins to enter a threshold where it can become physically painful and officially harmful as noise. Prolonged exposure at or above these elevated decibel levels significantly increases the risk of auditory damage, making standard measurement crucial for safety monitoring. To accurately measure acoustic exposure in various environments, sound level indicators known as decibel meters are used. These images illustrate two different styles of monitoring devices. On the left is a classic analog sound level indicator, featuring physical dials and a needle gauge to measure audio levels in decibels. On the right is a modern digital decibel meter, equipped with a top-mounted microphone and a clear digital display reading current sound levels. Devices like these allow safety professionals to monitor workplaces and ensure noise levels remain within safe operational limits. Noise pollution is broadly classified into two main categories based on its origin. First is community or environmental noise, which refers to non-industrial noise pollution affecting the general public. Key examples include aircraft operations, roadway traffic, and underwater noise pollution from shipping. The second category is occupational noise, also known as industrial noise pollution. This form occurs directly within working environments due to heavy machinery and production processes, presenting a specific hazard to workers exposed over long durations. Occupational noise generated within industrial environments originates from diverse machinery and mechanical processes. Common industrial sources include rotating rotors, meshing gears, turbulent fluid flow, impact machinery, electric motors, internal combustion engines, pneumatic tools, drilling, crushing, blasting, pumps, and compressors. The problem is often intensified indoors, as emitted sound waves reflect off hard floors, ceilings, and surrounding equipment, creating a highly reverberant and intense acoustic environment for nearby workers. 72 words. Occupational exposure limits define the maximum sound pressure levels and durations workers can experience repeatedly without damaging their hearing or speech perception. The standard occupational exposure limit is set at 85 decibels for an 8-hour workday. This threshold is established to protect the vast majority of workers from developing permanent noise-induced hearing impairment over a 40-year working career. Exceeding these limits without protective equipment significantly accelerates hearing loss and necessitates immediate safety intervention. Specific high-intensity noise hazards are prominent in rail transport and construction. In rail yards, retarders produce extreme high-frequency screeches reaching 120 decibels at 100 feet, translating to up to 140 decibels at a worker's ear. Meanwhile, urban construction, including roads, highways, and buildings, generates massive acoustic pollution. Primary construction sources include pneumatic hammers, air compressors, bulldozers, loaders, dump trucks with backup alarms, and pavement breakers, all demanding rigorous hearing protection. Recognizing the early symptoms of occupational hearing loss is vital for prevention. Initial indicators include a persistent feeling of fullness in the ear, muffled speech perception, and an inability to hear high-frequency sounds. Individuals may also experience tinnitus, a ringing sensation in the ears following exposure to loud sounds. Hearing loss can stem from long-term exposure or sudden acoustic trauma. When hearing fails to recover after an acute injury, it results in a permanent threshold shift, marking irreversible damage. The impacts of noise pollution extend far beyond hearing impairment, creating multifaceted psychological, physiological, and social issues. Chronic noise increases irritability, reduces human efficiency, and impairs concentration. Health risks include pupil dilation, mental illness, digestive issues, and heightened risks of cardiovascular events like heart attacks. Furthermore, noise causes temporary or permanent deafness, sleep disruption, and speech interference, while also negatively affecting animal behavior, crop quality, and structural property values. Noise mitigation encompasses targeted strategies designed to minimize acoustic hazard exposure. In industrial settings, constructing soundproof enclosures around noisy machinery isolates sound at the source. Regulations on motor vehicles are equally crucial, banning harsh multi-tone horns, requiring operational silencers or mufflers, and constructing vehicles to control exhaust noise. Furthermore, shifting airports and heavy industrial zones away from populated centers, enforcing public address curfews from 10 p.m. to 6 a.m., and planting roadside vegetation natural sound barriers effectively reduce environmental noise levels. Preventing noise-induced hearing loss requires personal action alongside structural controls. Individuals should remain mindful of surrounding noise levels, lower audio volumes when possible, and limit time spent in loud environments like sports arenas. Wearing adequate personal hearing protection, such as foam earplugs or earmuffs, is essential near heavy equipment. At home, regular appliance maintenance ensures worn rubber soundproofing insulation is replaced. Additionally, checking proximity to airports prior to purchasing a home helps minimize long-term environmental noise exposure. Effective noise mitigation relies on proven infrastructural and traffic management interventions. Key measures include installing roadside noise barriers to block sound propagation, enforcing reduced vehicle speed limits, and utilizing sound-absorbing roadway surface textures. Additionally, restricting heavy-duty vehicle access in sensitive areas helps control urban noise. Implementing smart traffic management systems smooths vehicle flow, reducing aggressive braking and acceleration, while innovative tire designs further reduce rolling road noise. Legislative frameworks provide essential enforcement tools to maintain safe noise levels across public and workplace domains. Under the Environment Protection Act of 1986, specific noise regulation rules set permissible ambient limits: 75 decibels for industrial areas, 65 decibels for commercial zones, and 55 decibels. Thank you.